All right, so chapter 6, we are talking about factoring and polynomials. So in this first one, we're just introducing two factoring techniques, the greatest common factor and factor by grouping. So for a lot of you, this should be familiar. Actually, for most of you, this should be familiar, but this is just a chance for us to get back up to speed, remember the steps, remember how to do this, get more into a comfortable state heading into the rest of the chapter. So we have three things to talk about in this section. The first is to identify GCDs, greatest common divisors or greatest common factors. It just depends on who you ask. Sometimes they say greatest common divisor, sometimes they say greatest common factor. I primarily say GCD, greatest common divisor, just because it makes a little bit more sense because you're looking for things that divide into multiple things. The second is factoring those GCFs or GCDs. We'll S there too. And then the last thing we'll be talking about is factor by grouping. And that will lead us right into the next section where we'll be using factor by grouping a lot. So when you're finding greatest common factors or greatest common divisors of polynomials, the first step is to find your greatest common divisor of the numerical coefficients. The second step is to find the GCD or GCF of the variable terms. And the third step is just to create the final answer, which is the product of those two. So you multiply the product of the answers in steps 1 and 2 to form the final answer. All right, so we're going to keep our looks specifically for polynomials because that's what we'll be working with primarily in this chapter. But we'll break it into pieces. So if you're told, for example, to find the GCD or GCF of 20x cubed y plus 10x squared y squared plus 35x cubed, we want to break this into two different problems using step 1 and step 2 from our little list here. The first is we want to find the GCD of 20, 10, and 35. So this is a problem you would have encountered in your last math class. Find the GCD of this set of three numbers. And so the way that I think about this is I break this down into their prime factors. So I know that 20 is 2 times 10, and I know that 10 is 2 times 5. And I know 10 here is 2 times 5, and 35 is 5 times 7. And so then I just find the biggest number that they have in common or multiple numbers that they have in common in their factors, their final prime factors. I see that they all have a 5 in common. So I know that my GCD for these three numbers is 5. And then the other problem I break this into is the GCD of x cubed y, x squared y squared, and x cubed. And so I treat the variables, when you're doing GCDs of variable terms, as prime numbers. So think of x and y as their own unique primes that have a specific value, those values being x and y, just like we think of 2 and 3 are distinct, unique prime numbers. We're going to think of x and y and any variable as prime numbers. So then I look for what they have in common. So I know this last term doesn't have any y's, so I can just cross out the y's altogether. And then just like we did over here, we take the largest value that is in common. So the largest value in common between x cubed, x squared, and x cubed is x squared. because x cubed can't go into this x squared, but x squared can go into both of these, can divide into both of these. And so our final answer then is 5x squared. That's our GCD. So I have some practice problems here that I encourage you to try out, factoring your GCDs, so getting used to finding your GCs, and then also go one step further and factor these polynomials. So I'm going to go ahead and give you the final answers so you can check your work. I recommend you just pause the video and try these out. They won't take you very long, but just try them out following the same steps, and then you can check your answers based on what I have here. So the answer here will be 4 times 2x plus 1. The answer here, so that means that 4 is your GCD. The answer here, our GCD is 3x, and that leaves 2x minus 1 plus 4x cubed. For number 3, the GCD is 4a, which is going to leave 1 minus 7a squared plus 16a to the 8th. And then finally, the GCD for number 4 here is x times y, which will leave us negative 3x squared plus 2x minus 5. So hopefully this feels familiar. If you're having trouble with these 4, come talk to me in office hours, send me a Canvas message, excuse me, and we'll get you through it. But there's some practice problems. Sorry, not practice problems. The homework problems, we'll focus in on these in a little bit more detail and give you lots of practice working through those. Remember, you get multiple attempts, so don't get discouraged. We want to get you back up to speed here. That's what we're doing. So now we want to talk about factor by grouping, which is kind of the bigger thing. And I find factor by grouping is easier to show you than it is to just explain how to do it. So let's take a look. So let's say we have this example here. We have 2 times x minus 5 plus 3a times x minus 5. So when you factor by grouping, you're given polynomials like you would have been in these 4 problems here, and just told factor by grouping. Your result should look something like this. And so to finish this now, what we can do is, if we think of this as a and a, we have 2a plus 3a, well, maybe a is a bad choice since we already have an a there. We have 2b, let's think of it as b, and then 3ab. The b represents x minus 5, so I can factor the b out, and we're comfortable seeing that b get factored out, 2 plus 3a. But the b is x minus 5, so what we've really done is factored x minus 5 as a binomial out to the front, and then what's left over is 2 plus 3a, which is what we have right here. So this is 2 ways you can think about it. Some people really like doing this intermediate step where you switch to a single variable and then it feels more like regular factoring, and then you switch back. But you are allowed to factor whole binomials because it's multiplication. And so I can factor that whole x minus 5 all the way out to this final answer before I do any swapping or changing to b. So let's see what I mean in number 2 here. So I have x squared plus 5y. I can take this whole binomial and factor it to the front and have x squared plus 5y. And then remember, when you factor, it's dividing. That's why GCD is the equivalent term to GCF, because you're finding divisors because you are dividing. So what's left over if these are gone and factored to the front? Well, you can't divide and get 0, so there's a 1 here. And so we have 7x minus 1. And that's our final factored version. So this is, as I said at the start of number 1 here, this is kind of the end result when you are told to factor by grouping. So if we flip the page here, factor by grouping, the whole process is where we group terms using parentheses. Then we factor to get results similar to the previous 2 problems. So let's walk through one all the way. This just says factor by grouping. So when you group terms using parentheses, you choose where the parentheses go. So I'm going to pick parentheses like this. And for most people, this is how they do it. They just put their parentheses down. But you are allowed to move these around. So I could rewrite this as AB plus 2B minus 6A minus 12. And then I can factor differently. I could group these two together. Now, I show you this because when you group like this and your negative is outside these parentheses, what you have in effect done is divided each of your negative 6A and your negative 12 by this negative that's already out there. So this needs to get changed to a plus 12 instead of minus 12. So you now have minus parentheses 6A plus 12. So let's look at how both of these two things play out. So in this first one, I can factor an A out of this group, and I have B minus 6. And out of the second group, I can factor a 2. And I'll have 2 times B minus 6. And the nice thing about factor by grouping is you have a built-in check. You know you've done your factoring correct if your binomials here are the same. So I have B minus 6 and B minus 6, so I know I did that one right. So now let's see what happens when we factor here. Here I can factor out a B, and I get A plus 2 left over. And here I can factor out 6, and I have A plus 2 left over, because 12 divided by 6 is 2. So again, I know I've done this right because I have A plus 2 on both of these. Now notice we have two different expressions. So we have A times, let's say this is 1 and 2. So we have A times B minus 6 plus 2 times B minus 6. And for number 2 here, we have B times A plus 2 minus 6 times A plus 2. Now we know, as I just said, we factored correctly. We have the same binomials in each pair, so we know we've done it right. So what's happening here is when you group your things differently in different orders, you make certain factors, certain binomials appear. So in this first grouping that I've labeled number 1, I forced B minus 6 to appear. But by reordering my terms and factoring something different out, I've forced A plus 2 to appear. So you may be able to guess, if you can't see it already, what the answer is. When I factor B minus 6 out up here, what's left is an A plus 2, which is exactly what we had down here. And down here, when I factor the A plus 2 out, what's left is a B minus 6, which is one and the same. So it doesn't matter how you group up your terms. The big thing you want to remember is if you group inside a negative, you do need to switch your sign inside the second term. So this was negative 12, so it became positive 12 when I put the parenthesis inside the negative. If it was a positive 12, it would have become a negative 12. But in either case, these are the same answer, and they are the correct answer. And we factored by grouping. So again, I've got some practice problems here for you to try. And again, I'll give you the final answer so you can check your work. The final answer to number 1, you should have x plus 5 times x squared plus 3. Now you could have x squared plus 3 times x plus 5, just like here, they can go in any order, it doesn't matter. Number 2, you should end up with m squared minus 2 and n squared plus 1. And number 3, you should end up with y plus 2 and then x minus 1. All right, so try out this factor by grouping. Follow the steps that we did in either of these. Remember, you can reorder, just like we did here for 2, line 2. But it doesn't matter how you group up your terms in these 3. These are your final answers. So if you're having trouble with these, again, come see me in office hours, send me a message in Canvas, and we'll see if we can get you squared away. But that's going to be the end of 6.1.